Thanks again for joining. Super excited about this Demo Days session with MLOps World. A lot of what we do ends up into ML engineering, having to deploy the solutions. So it's awesome to be able to talk with the MLOps World community. And discuss like what are the current challenges, the current solutions, how we can work better with Hugging Face. I'm Jeff Boudier. I lead the product team at Hugging Face. If you want to contact me directly, I'm sure you can find on the Hopin interface how to chat, but my email is jeff@huggingface.co. Feel free to reach out to me directly. So in this session, my gradient descent of sorts, I want to give you some context about why we do what we do at Hugging Face, our history and the history of transformers over the last couple of years, discuss some of the trends that we see in the industry, tell you about all the latest developments, features, products, services that we've came out with over the past few months. And then, of course, I'm super excited to test things out with you live in the demo part of this session, which we'll do after a round of Q&A. All right. So to start here, I want to bring it back to why we do what we do at Hugging Face. And it is that we think that productivity in NLP is going to be one of the main sources of growth, of productivity growth for companies and consumer alike over the next 10 years. And the reason for that is that text is basically the API for humans. That's how I spent most of my day until now, whether it's in Slack, whether it's in Gmail, whether it's talking directly to people. All of that happens in natural language. And the way that people interact with companies is also directly in natural languages, whether it's customer support or putting out marketing messages, communications, product features, everything is expressed in natural language, and that makes text the API for humans, and that's why it's so important to be able to make it more productive. So that's why we do what we do, and how it all started is through this seminal paper, Attention is All You Need, that introduced from Google Brain, that introduced the transformer architecture. And that's what changed the world of machine learning. And that's what we decided at Hugging Face to gather the community around to propel this new era of machine learning. The main thing that was brought by the transformer architecture is the notion of transfer learning. In more classical machine learning, you're looking at a problem, you have to gather a whole bunch of data, you have to create a model from scratch. And then if you're looking at a different problem or a problem that may need to be updated or tweaked, then you have to start that whole process all over again. And with transfer learning, we're able to leverage massive amounts of data that have been used to create massive models that accumulated a whole bunch of knowledge, so that when you need to do a slightly different problem or work on slightly different data, then all you need to do is to do this process of fine-tuning, leveraging the accumulated knowledge of the pre-trained model to adapt it to your task. That's transfer learning, and that's changed the world of transfer learning, starting with machine learning, starting with NLP. So that's how it all started, right? BERT was introduced shortly thereafter the paper I just mentioned. And with BERT came a rapid explosion of performance of NLP tasks, starting with text classification, where within a year, the scientific community was able to surpass the human baseline, making computers better than humans at classifying text. And then question answering shortly thereafter with the Stanford squad benchmark that was quickly overcome. And so Stanford came up with Squad 2.0, which 6 months later was also quickly overcome. So the progress of the field has been really breathtaking, and our role in this is really to make this latest science available to as many scientists, to as many machine learning engineers, to as many companies and researchers as possible. And that's what Hugging Face does through our open source, through our open science contributions, and through our products. Our mission is to democratize NLP. Actually, over the last 6 months, it's kind of changed in scope as transformers have started eating the world of machine learning. So we've invested a lot over the past few months in audio and speech modalities. So today, transformers reach state of the art for most speech-related tasks, and you can use them directly in our open source and our products. And transformers have started showing incredible results on vision as well. So our mission is the same. It is to democratize the latest science, but we're looking at machine learning as a whole, as the impact of transformers is quickly expanding through all the different modalities in the field. When I talk about democratization, there is a graph. It's actually a pretty old graph that I like to show, and it's this one. And what it shows is over time, the introduction of new model architectures. Here's looking at NLP specifically, from the seminal BERT all the way to Turing NLG, not even featuring GPT-3, Switch, and the latest architectures. But already then, already a year ago, we could see this exponential trend in the size of the models, measured here by the number of parameters of the models. And that has a couple consequences that touch directly to our mission of democratization. The first one is, as the size of these models increase exponentially, it introduces a whole bunch of challenges for machine learning engineers and MLOps to put these models into use, into production. It requires a lot of special infrastructure, a lot of special logic to make it scale. So that's a problem for democratization, one that we want to solve. And then the other trend that we see that is maybe less visible by looking at this graph is, as the amount of resources that are required to innovate and offer new architectures and bigger and better models increases, then you see the relative contribution of institutions, of public research labs and universities to start ebbing away. And we think that's also an issue that is close to our mission, and we want to make sure to be the distribution vehicle for the latest science that comes from contributors from the largest tech companies in the world to the university, to the individual contributors. That's why we built Hugging Face as this place where the community gathers to contribute the latest science, to access the latest science and make use of it. So the way that we democratize machine learning, there are really two pillars that are very important. The first one I started talking about is community, and the other is efficiency. So community is one of the main defining characteristics of everything that we do at Hugging Face, and it touches to that mission of democratization. So today, Hugging Face is a team of over 50 people, but we represent a community that's much bigger than that. There are over 1,000 contributors to Transformers, our main open source library today. And contributors have brought over 15,000 models, model checkpoints that are directly, publicly, freely available within the Hugging Face Model Hub. These models are available in the widest range of languages, which is another aspect of a community that's and democratization that's very important to us, which is that the latest science, the state of the art, can be used, whatever language, whatever country you are building solutions in. So we regularly invite the community to join us in sprints where we will take the latest state-of-the-art models like Wave 2 Vec 2 very recently, and then fine-tune it into as many languages as possible, so people all over the world can benefit from the productivity boost that Transformers provides. So this community-driven approach has really fueled the adoption of our open source. Here I'm comparing the GitHub stars over time with some awesome open source projects to illustrate that really over the past couple years, the adoption of Transformers, our main open source library, has been really breathtaking. And today it's pretty much the reference toolkit that data scientists and machine learning engineers all over the world use in order to leverage Transformers on their business cases. That led us to today, I think we have over 2 million downloads, pip installs of the library every month. So it's awesome to be seeing the impact of our open source. By the way, I put a couple poll questions in the chat, and after the talk, we can look at the results together and discuss. What is this all used for? I think you're familiar with typical here NLP use cases, but to illustrate that, okay, we have 2 million downloads of the library every month. But because it is open source, the magic is that these companies, don't need to ask us or talk to us to use it and do some amazing things. So it's great when we see companies come forward and explain how they're using Transformers for their use cases or reach out to us. That's how we know these companies are using Transformers. Some typical use cases: automating, accelerating business processes like customer support through text classification, through conversational interfaces, accelerating and improving the user experience in search use cases, question answering, information retrieval, and of course, analyzing, understanding natural language, like Bloomberg in this example, to make sense of news articles. Okay, so I talked about community, and then I want to talk about efficiency, because one of the main benefits of transfer learning is that you can reuse models that have cost millions of dollars of compute to create, and then use that as a base upon which to fine-tune for your use case. And what that does is it really reduces the global computational cost of adopting the technology of Transformers. If you compare that to classical machine learning, where every single business problem by every single company requires data scientists to start from scratch and create a new model. We want to go further, though. As I said, the Transformers models are getting bigger and bigger, and that means that putting them in production requires a lot of effort, but also energy. And so some of the state-of-the-art techniques that we have pioneered, I'm mentioning here. So of course, Distilbert, through the technique of knowledge distillation, This is today one of the two most popular models that are being used and downloaded by our community. So that shows the impact of that research in practice, where we're able to conserve 98% of the performance of BERT on the glue benchmark while providing a model that's 40% smaller and 60% faster. So the gain in terms of energy, the gain in terms of latency is important. Another more recent technique is movement pruning, which was introduced by a recent paper by Victor San, researcher in our team, with our Chief Science Officer, Thomas Wolf, and Dr. Rush, which allows, through fine-tuning, to remove a lot of the model weights and size of the model while conserving great accuracy. And then also a new research area in which Hugging Face is leading the field is around sparsity and model compression using new techniques like block sparsity. All right. So this is the history of Hugging Face, and through the history of Hugging Face, it's pretty much the history of transformers as a model architecture. Now maybe I'll take a little pause and see if there are any questions in the chat. Let me come back to us. Hold on, I need to get my... I lost my cursor. Oh, sorry. I cannot get my cursor back. Here we go. Chat. Can Hugging Face models be used in another commercial product? For instance, a new AutoML product. So that's a great question. So as I said, Hugging Face hosts over 15,000 model checkpoints. Some of these models have been implemented and contributed to by Hugging Face. Some of these models have been contributed to by the community. So it's important to refer to the model card, which may have superseding specifications on the licensing terms of that model. When in doubt, always reach out to the model contributor to ask them. I noticed the recent addition of Elasticsearch and face indices to the dataset class. Are you aware of anyone using Hugging Face for info retrieval? Yes, Anne. Information retrieval and using transformers to extract the vector representation of natural language is a very important use case, and one that we're looking to really invest a lot more in through our solutions and also through our open source integrations. We recently welcomed to the team the main author of the Sentence Transformers library, which is today the state of the art in terms of vector representation extraction. And so it is being more and more integrated into the library. You can use now new widgets to test those models directly. All right. So let me go back to my talk, and I will now switch to the second part, which is what's new with Hugging Face. So I talked about all these thousands of models, and so this is an amazing resource for the community to be able to discover, but also test and download and access the latest models that have been contributed to by the community, the latest models that have been implemented within the libraries. So I will demo that to you to walk you through how to use it and what you can do with it. But this is today one of the most used tools by our community, by users of our open source, to orient themselves and to try things out with all the new features and models and libraries that are coming out. Some of the main things that I'll be touching on through the demo is that for us, a model or a data set is really a repository. And we're building it this way, we're architecting it this way to be able to provide a full version control on your models, the same way that you're used to have version control for your software. And then the other exciting new feature is the ability for people or companies to manage their models privately, the same way that you could publish models publicly and manage them. So an amazing tool for organizations, teams to share their work, enabling people to build upon it, version control it, and try models out. Then the next thing is, so that was the private models is kind of the first question that came out when we were asking users, how can we make your work easier? The second thing that comes out is that Transformers is still very much in the research stage of adoption within companies. I think that most data scientists today that do work that connects with NLP use Hugging Face and Transformers to do their work. But translating this into new modalities, new business problems requires lots of, there's a learning curve. And so for that, we created this expert acceleration program, which is really a premium support service where companies have direct access to our team to ask questions and get expert guidance on like what's the best model architecture for my problem. I need to fine tune this model with my data, like what's the best format, what's the best way to leverage distribution, how do I use the new Hugging Face solution in SageMaker, and then on the production side, I need to accelerate my model 2, 3, 5x. How can I do it? So yeah, basically it's premium support from training to deployment. Another thing that's new is Auto NLP. And Auto NLP is a way to very easily create state-of-the-art models with your own data, where you don't want to dive into all the different architectures that exist. Why should I use BERT or Roberta or Distilbert, Albert, Diberta? No, you just upload CSV or JSON file of training data and say, make me a model for this task. And so, yeah, a 3-step process that makes it super easy for data scientists to do their work and get candidates models that are directly evaluated and also deployed so you can serve them directly through our API. Another thing that's new is an amazing integration of the Hugging Face ecosystem within Amazon SageMaker. In talking with data science teams all over the world, we really recognized that SageMaker is one of the main tools that enables data scientists to have a lot of productivity. And so we were excited to partner with the Amazon team to bring a very easy to use way to use Hugging Face within SageMaker today to train new models, leveraging all the great stuff that SageMaker provides, right? So data parallelism, model parallelism, using spot instances to reduce your cost, using all the great evaluation and metrics tracking features that the SageMaker ecosystem provides. And what is also new is our accelerated inference API. So I talked about training models through Auto NLP, bringing models, but what if you want to serve them in your applications, in your system? That's what the accelerated inference API is for. So any of those 14,000 models, you can actually try them out for free, and we'll do that in the demo without even creating an account. All this is powered by our accelerated inference API. And for companies that want to integrate that in their own apps, we have subscription plans for that, where it's a very simple API to query any of those models and scale up usage. And right, the main attraction here is that we're able to get 10x speed up compared to what one would get by deploying simply our open source in their environment by optimizing the model architectures for speed. And speaking of speed, I have a bit of a tease here. I'm not going to go into too much detail, but I talked about how efficiency is so important for us, and we want to make transformers as fast as the machine learning of yesterday. And so, yeah, I have this bit of a tease. 10x speed up isn't cool. You know what's cool? 100x speed up. So that's a project that we're working for, and are looking for beta partners to work with us. So if that's interesting to you, then please send me an email at jeff@huggingface.co, and then I'll take it from there. All right. So that concludes this part of the talk. I talked about the history of transformers, the history of Hugging Face, about the latest products and services that we came out with over the last 2-3 months. So now I'll go back to our session and take your questions. And I don't see any new questions. So what I'll do is I'll look at the poll results and comment them with you. I haven't seen the results show up. So the two questions that I asked were, what do you use Hugging Face mostly for? Assuming that you use Hugging Face, whether to research models or train models or deploy models, and then whether you use Hugging Face in your day-to-day. Since I can't see any answers there, I'll just ask you now, and if you want to put in the chat, that's something we can talk about it. Can you tell about AutoNLP? Yes. So AutoNLP is a new service and library. You can find it on GitHub /huggingface/AutoNLP, where you can just select a task and upload your training data and launch a training job. The training job will target a curated list of base model architectures, and we'll do some hyperparameter optimization to create, evaluate, and deploy a set of candidates that will give you the best accuracy and performance. So you launch your training job. You can see all the models that are being created for you. Once they're created, they're evaluated. You see the metrics, and you're able, and they're already deployed, so you can serve them using the accelerated API I talked about. Something to mention. So with AutoNLP, we just released today a new task with question answering. I saw Abhishek tweet that earlier today. So what kind of tasks can you target? Well, you can do sentiment analysis. You can do information retrieval. You can do entity recognition. You can do binary classification. You can do multi-class classification. You can do summarization. You can do speech recognition. And now, starting today, you can also do question answering. Here, let me type the URL so you can go to it directly. Right, and the other piece is languages, right? So you can select to create a model targeting a specific language, and I think we have about 10 languages that we support today. If there are languages that we need to support, new languages, then you can let us know through a feature request, and we'll integrate it quickly. All right, how to go about data labeling for NLP problems. If you do not have labeled data, how to go about transfer learning and use Hugging Face. So that's a great question, and I think well, I can talk about it a little bit, but really I want to show you, right? So transfer learning is I have training data. I'm going to use a pre-trained model, and then I'm going to fine tune with my training data to get better accuracy for my specific business problem and to adapt the model to respond in the way that I want to. That is to respond according to the task. Now, if you don't have training data available, you can still take advantage of the accumulated language, the accumulated knowledge of large language models. And these are techniques like zero-shot classification or few-shot learning that I will demonstrate shortly. And then regarding polls, he showed me the result when I voted. So if you vote on yourself, I'll see the result. Perfect. Thank you. Thanks for the tip. I'm going to do that right now. Yes, I use Hugging Face every day. I said, oh, wow. So half of you actually never used it. That's really cool to know. And a third of you use it only to experiment with things. Very cool. And now how do you use Hugging Face mostly for? So me is researching models. And I see, oh yeah, I'm in the majority. 2/3 of us use it mostly to research models, one third to train models, and 7% or 1% here, 2. So now it's 12 to deploy models. Cool. Well, thank you for playing this game with me. We'll go back to it once we're done with the demo. Cool. Now, let me go to. I'm going to share my screen, but now my browser, so I can walk you through some stuff. All right, huggingface.co or hf.co now for short is where you're going to be able to access these 15,000 models. This I think we have over 1,500 data sets now publicly available, and work with them. So the first thing that I want to show you is what I talked about with the Model Hub. How do you access, how do you edit, how do you manage, how do you use all these different models? And most importantly, how do you find all these models? So first stop for me is really to talk about the tasks. The tasks represent what each of those models has been fine-tuned and or configured to do in terms of output. The tasks map to the feature of transformers we call pipelines, where pipelines provides a high-level abstraction around the models that takes care of the pre-processing, the tokenization, the actual model inference, and the post-processing, so that you can feed it natural language in and get the result in the format that you expected out. And so through these pipelines, we're able to offer ready-to-use models that are set up for all these different tasks. So finding the models that correspond to the task you're looking for now is as easy as selecting one of these filters, which correspond to the tags that you can specify yourself when you upload a model, right? So fill mask is one of the seminal pre-training tasks that base models are trained on. And then typically, for instance, a BERT model can be fine-tuned to do sentiment analysis, token classification, natural entity recognition, question answering, etc. So by simply selecting the task, you'll get a lot of value to quickly zero in on the models that you're looking for. Then maybe here I'm looking at translation models, but specifically I want to translate from French to English. So by selecting the language tag, then you can narrow down further to the languages that you're looking for. So by selecting translation, I went from the 14,000 models to about 1,400 models. And then by selecting French, now I have 200 candidate models that I can go and look at. Then another thing that I want to point out here while you research models is libraries. Of course, you can filter by the main framework that you are working in, whether it's PyTorch or TensorFlow. We very recently, a couple of weeks ago, I think, introduced JAX as one of the main frameworks we support, which is really, really cool. And we already have over 3,000 model checkpoints that are available for JAX. So if this is part of your tool set, you'll be super excited to see that. And then one important thing that is absolutely not obvious is that we intend for the Hugging Face Model Hub to be where the whole AI community comes to contribute models. Whether these models are contributed to or through the Hugging Face open source transformers or not. So we started offering the Model Hub for third-party open source libraries for them to use it as the distribution vehicles, for their models or models of their community. So now you can use Hugging Face to search models that have been contributed from the sentence transformers library, for instance, or audio models that have been contributed by the Pianote library or by their community. Vision models corresponding to the team library, models from Allen NLP, or models from other libraries. So think as the Hugging Face Model Hub, not just as a way to interact with transformer models, but as a way to explore all the models that have been contributed by the AI community, regardless of the library they were created for. Cool. So now I want to go into more detail. So what do you do once you found a model that sounds like it could be a great candidate for your use case? So the first thing is we encourage the community to fill out with as much important information as possible within the model card. So the first thing is to have a thorough look at the provided information. We had a question earlier about licenses, how to use the model, where are the potential bias that have been identified for this model. All this is super important to consider. And so that's one of the first steps. The next step is like, how do I use this model? Well, for each of these models, you can just use it right from the page. And as I mentioned earlier, this is powered by our accelerated inference API. And here I'm logged into my account, but even if you don't have an account, you can use this to some extent for free. But if you want to integrate it into your apps, that's where the accelerated API comes into play. So by just clicking this button, it will give you a code snippet, so you can integrate that within your app to serve programmatically this model within your environment. And then another topic that I discussed earlier is I want to use this model to fine tune it in SageMaker. Like, how do I do? Well, we have functionality for that. So if you click use in SageMaker, and maybe I should increase the size so you can see better. Sorry about that. You select the task that you want to train your model on. So maybe it's summarization, whether you want to do this on your local machine or in your AWS. And then we provide you with the scripts you can directly paste into your development environment to launch a training job. If you need more information on this, we have useful links for you to access sample notebooks, example scripts, and information about how this all works. Cool. So that's how you use the model. The next thing I want to show you is, how I talked about earlier, then for us, a model or data set, that's a repository. Well, this is where you can have access to the actual repo. For each model or data set, you have access to all the atomic files that are part of the model repo. You can, of course, download them. You can simply view them, and you can also actually edit them. So it's a great way for model contributors to quickly update their model card to understand through the configuration what are the main hyperparameters for the model. Because this is a repo and it's using Git as the way to work, then every single edit is going to be tracked through commits, right? So the next thing that we can look at is that for every single file, all the modifications will be tracked with their different commits. So you have the full history of the modifications of each of the file. And for the model itself, you have access to the complete history of the commits on that model, which then enables you to target a specific version of it in your code. So the performance is stable as the model evolves. All right. So I talked about how to get into, how to find a model, how to use the model, how to see what's in the model, how to see the history of a model, how to edit a model card or a file within the model. And I think maybe what would make sense to show you next is what if I want to create and manage models specifically for my organization and keeping them private. And so using the Hugging Face platform as a way to collaborate within a data science team or within different parts of an organization. So once you have a subscription to the Hugging Face platforms, and we have paid plans for individuals as well as organizations, you have the ability to create new models, not just publicly, but also privately. You can create them privately to you, or you can create them privately to your organization. So if I create a new model repo private to me, that's going to be called MLOps World, then you can do so. And from there, create a model card, upload files from the Hugging Face website or from the Transformers library. We make it so that it's really easy to push new model versions to Hugging Face, whether from the Transformers library as you train models, or within our cloud environment. All right. So now, I talked about private models, and I talked about what to do with what you can do with models to use them and interact with them. And I guess I should mention that everything that I demonstrated to you for models is also true for data sets. We have over 1,500 publicly available data sets to access, use, and evaluate. And all of these data sets are also organized by types of task and languages. And so it's a very easy way for you as you think about your next business problem and what data set can I use that would be most relevant to the type of data that you're going to be processing. Then it's a really easy way to do so. So if I wanted to do a text classification, more specifically sentiment classification for German text, then I have 3 public data sets available, which I can get information about before I start to work on it, including the important information about biases, and about licensing. And I can explore those data sets directly to see a sample of the data that is contained. Okay, so now let me pause for a bit and go back to you, see if there are any questions so far. Any new questions? How many of your approximately 15,000 models are private? The private model functionality is pretty new. I think we introduced it maybe 6 months ago. The overwhelming majority of the models are public. For the next round of demos, what I'm planning to do is to show you a specific type of models so we can actually play with them. I talked about the expansion from NLP to speech and vision, so we'll be able to try all these different modalities. So I'm going to start with text, and let me go back to sharing my screen. Okay, here we go. So I'm back to the Model Hub where all the models are present. And the first thing that I want to do is I want to summarize some articles. So again, I go to my task selection. I look for the summarization task. I get 230 results. I'm going to try the most downloaded model, which has been distilled, and so should be smaller and run faster than the base model it came from. And then next, I'm going to go to the New York Times. How do I switch tab? Sharing interface. Let me see what you see. Oh no, you're still on my tab. Okay, so I'm going to, you're gonna have to trust me that I'm going to the New York Times homepage. I'm selecting the first article at the top. I'm taking the first 3 paragraphs of the article, and then I'm coming back to you. I'm gonna use the hosted inference widget and just paste it, these 3 paragraphs. Consumer prices rose at the fastest annual rate since 2008 in May, a bigger jump that economists had expected and one that is sure to keep inflation at the center of political and economic debate in Washington. The consumer price index surged 5% in May from a year prior. The Labor Department said on Thursday, economists had expected an increase of 4.7%. The price index rose 0.6% from April to May, compared with forecasts with a 0.5% gain. It's funny, this sounds like an automatically generated article. An index excluding volatile food and energy costs rose 3.8% from a year earlier. The briskest paced since June 1992. Well, good luck summarizing that. But let's try anyways. So here's what we got. The inference time, and here it's on CPU, so it can be accelerated using our accelerated inference service on CPU or GPU. But on CPU, so you get 2.5 seconds to give us the consumer price index surged 5% in May from a year prior. That's correct. Economists had expected an increase of 4.7%. Yes. Price index rose 0.6% from April to May, compared with forecasts for a 0.5% gain. And the index, excluding volatile food and energy costs, rose 3.8%. I'd say that's pretty good. Great. So that's summarization. Next up, I want to talk to you about zero-shot classification. And that's going back to the question we had earlier about how can I get transformer-like performance if I don't have label training data for my use case. And so one answer to that is a zero-shot classification. So here again, I'm filtering the models to zero-shot classification. I see that there are 18 pre-trained and fine-tuned checkpoints available. I'm going to select this most downloaded model recently that has been contributed by Typeform. It has been downloaded over 100,000 times this last month. You can see the evaluation results and information that's been contributed to by Typeform when they added this model. So let's look at the widgets and what it does. So here with the default example, what we have is a document, a piece of text, and we're asking the model, is this about space and cosmos? Is this about scientific discovery? Is this about microbiology? Is this about robots? Is this about archaeology? And you see, for each of those classes, I'm repeating the question, and that's exactly how zero-shot classification works. It is a classification task that is sort of repeated in this prompted way with one forward pass per class. And so here the computation wasn't done live because it's a cached example. But what I'll do is I'll remove a word to make this different, and then I'll ask the model also if it's about history. Let's compute it. So here within, you may not be able to see this, but within half a second, the model was able to tell us, that this document was most probably about space and cosmos, but could also be about microbiology, scientific discovery with this distribution of probability. So this is how zero-shot classification works, and what we found is that it gives really compelling results. So typically for use cases like, for instance, customer support, where you get tickets from customers and you're wondering whether that ticket should go to this team or that team. You're wondering whether this is about their new iPhone, or is it about an iPad or an AirPod, or what is this about? Then zero-shot classification gives you flexibility to define, to let users define their own classes without you having to retraining models. So it's definitely an architecture that is getting a lot of traction among the community. Maybe I'll take a little pause from the models to talk about organizations. So here I'm taking the example of an organization here, Typeform. that is using Hugging Face as a way to share with the world the models that they have created, and to collaborate internally within their teams by sharing private versions of models so that everybody within the team can experiment with them, access them via the Hugging Face platform, or access them via the Transformers library. So it's a seamless way to integrate models privately within your workflow and share them with your team. So after zero-shot classification, still on the theme of how do I do if I don't have an extensive set of training data to fine-tune a pre-trained model with. Another technique is few-shot learning. And few-shot learning is the ability to, not the ability, the technique to tell the model at inference time what you are expecting through examples. So it's a type of prompt engineering, if you heard the term, in relation to GPT-3. But it's a technique that allows you to tell the model what you are expecting from it at inference time. And to demo this, I will take you to the blog post which we published last week about GPT-Neo. So let me share that with you. Oh, and I see we have a question. Hi, Jeff. Do you have a language detection model? Language detection model. That's a good question. Let me go to the model hub. Yeah, language identification. We don't have a filter in the model hub specifically for this, but it seems like a very doable machine learning problem. Yeah, I can find in a few seconds like available models that correspond to that. But that sounds like a very very doable problem to solve. Something that we would probably look through our expert acceleration program to guide people on how to approach it. So yeah, this is the blog post I was referring to that allows you to play with GPT-Neo and understand in practice how few-shot learning works. This is the same sort of experience that you can have with GPT-3, but here you can do it right there from the blog post, so it's a very accessible. So a quick note about GPT-Neo. This is a project from the Eleuther AI team, which you should check out. And what they are doing is they are collaborating to create an open source alternative to GPT-3. Right? To use GPT-3, you need to use a hosted service that's provided by OpenAI or Microsoft. But so if you want to use an open source alternative, that's what GPT-Neo aims to be. And the first checkpoints from the Eleuther AI team are available on the Hugging Face Model Hub. They were shared by the team. And so we have the 1.3 billion parameter checkpoint, and we have a 2.7 parameter checkpoint that you can play with. So in this blog post, we walk the reader through what is few-shot learning, how to use it, and how it works. And we talk about GPT Neo. We talk about how you can use GPT Neo with the Accelerated Inference API, our hosted service. What are some good practices in few-shot learning and some mistakes to avoid. And one thing that's very important, and I'll talk about it more at the end of the talk, is how to use these models responsibly. Okay, but here for the demo, let's just play around with it. So let's say that here I have some prompts that are already filled that enable you to, at inference time, tell the model through a few examples. So here's one example. Here's a second example. Here's a third example. Based on these three examples, you tell the model to complete the prompt. So for this question answering, based on the two examples actually, the question is, in which division are the Jets playing, based on the context provided above, and the response is the AFC East division. So let's read the text. The New York Jets are a professional American football team based in the New York metropolitan area. The Jets compete in the National Football League as a member club of the league's American Football Conference East division. So yes, the Jets are playing in the AFC East division. So that's using GPT Neo 2.7 billion parameter version out of the box. But let's say you want to use the same model, but this time you want to do sentiment analysis. And so here I have three examples. Tweet, I hate it when my phone battery dies. The sentiment is negative. Another one and another one. And so I'm going to prompt the model with another tweet. I am a happy disabled person. And the response from the model will be negative. And that's one of the very important points that I want to make through this demo, is that the models are only as smart as the data that they have been fed. And so they will output biased data if they are trained with biased data. Because to be able in order to have this sort of advanced performance and this flexibility of few-shot learning, you need very large models. The very large models that have those capabilities have been pre-trained with most of the text that exists today on the internet. And so they contain a lot of the biases of the information that they have been trained for. So it's super important when using these large language models to follow responsible use guidelines, so that in that case, say you were rating reviews from a product, and one of these reviews saying, I am a happy disabled person, then the human in the loop, or the way you're implementing the features, would not negatively classify this review, which is in fact positive. If I run it again, the model will give slightly different predictions every time, showing you that the confidence of the model into the prediction isn't really great. And then to continue the demo on GPT Neo, this sentiment analysis and question answering, the task that I just demoed, they're sort of quintessential NLP tasks. But GPT Neo can also do code, right? So if you tell it that a red button that says stop should correspond in HTML into this code, and give it another example for something different, because the training data contained a lot of HTML, then it's able to generate the HTML snippet that corresponds to this description, a headline saying "Welcome to AI," which is actually rendered here. So the same goes with SQL generation, which is very interesting to make advanced querying more accessible to people by just feeding GPT-Neo 3 example of what of the question that is asked and what is the corresponding SQL query. Then GPT-Neo can give you here the query that would correspond to fetch the 3 max salaries from the worker table. Yeah, it's yeah. So yeah, I encourage you to play around with it and write your own prompts. Play with, see how the results differ depending on the temperature parameter that you use. And when you do so, please read the blog post. It will give you a lot of pointers. So I've covered zero-shot classification, few-shot learning, which are 2 techniques that are super useful when you don't have a lot of training data, or when the classes, the problem that you're going to be using to classify are changing or can be submitted, specified by users. So before I jump to speech and vision, let me go back to the questions. Does Hugging Face have a postal address parser model? Well, the way to figure that out would be to use the search within the model hub, and to rely on the model contributors giving good metadata for their models, which is a good plug for me to say that when you do contribute models for the community, it's super important that you provide as much metadata as possible for people to understand, what data set this has been trained on, what are the evaluation metrics if you have them, what are the detected biases inherent to that model. So here I'm back to the model hub, right? And I'm going to search with address. I see that there are 2 models that have been specifically, well, here's by the model name. It has address in the name, so it may be a suitable model, but in order to be able to use it, we would need to add some metadata, a config.json file, to assign it a task so that it would run within the API. And then we have an address corrector. Again, without the model card, it's harder for the community to make use of the models. So we encourage people who contribute models to add their data. Cool. So let me walk you through speech recognition. Then we are hosting a ton of speech recognition models. There are model architectures that have been contributed to in partnership with Facebook and other leading research labs and teams that have enabled the community to contribute and to create a lot of new models. So the task that I'm going to be looking at here is automatic speech recognition, which is to say speech transcription. We'll look at the Wave 2 Vec2 base model contributed to by Facebook, and take it for a spin. So here the widget, which I'll maximize now, enables you to provide an audio file or to record your own. The model has been trained for English. So hi, Machine Learning Ops. I'm super excited to present to you today. So I just recorded, hi, Machine Learning Ops, and now we're going to compute this. The model is currently loading within the API so that we can run inference on it. And once it is, then it will serve the model, give us the inference time and the output. This model has been trained on, so now we have the output. So on CPU, with the free version of the API, the output was computed in less than a second. And this is what my broken English gave us in terms of transcription. Machine Learning Ops, I'm super excited to present to you today. So yeah, pretty good. And you can learn all about the model through the model card. And something that was super exciting months or so ago, we invited the community to join us in a sprint to make this wave-to-vector architecture pre-trained in as many languages as possible. And we had, I think, over 300 people who came and joined us in this sprint and contributed models in over 100 languages. So that's super exciting, and maybe I'll have better transcription result, better accuracy if I talk in my native language, which is French. So let's go to automatic speech recognition. And again, select a language, so French. And I'll pick this model and record. Bonjour, je m'appelle Jean-François et je suis ravi de vous rencontrer. Bonjour, je m'appelle Jean-François. Okay, so we'll load the model again. As we have over 14,000 models, we can have them all ready to serve through the API, but we want to be able to serve them all. So we have this dynamic model loading system so that when you request a model that is not currently in memory, it will be first loaded before running inference. For subscribing organizations, we have a feature called model pinning to give your private endpoints the ability to have models always ready for inference 24/7. So this time, the transcription is right on point. Bonjour, je m'appelle Jean-François, je suis ravi de vous rencontrer. Which tells me that I still have a pretty thick accent. All right, so that's for speech. Let me go back to our session and see if I have new questions. I don't, so then I will move to the last part of this demo, which is vision. All right, back to the Model Hub. So there are a few tasks that are dedicated to vision now, and I'm going to look at image classification with this new model that's been contributed to by Google, VIT, Vision Transformer, and was introduced in the 4.6 version of the Transformer library, which was released, I think, about a week or two ago. Probably a couple of weeks. So the way that you can interact with this model on its page is by simply providing it an image, and then we'll classify it. So I have one image ready. I'll upload it to the model, and I get the classes back. And so here, much amazed, we have 52% probability for Eskimo dog husky, which is pretty much on point. So that's Vision Transformer. You can try it now on the Model Hub and with the Transformers library. Another model that you should definitely check out is DIT, contributed to by Facebook. So this is another image classification model that was also introduced in the 4.6 version of Transformer. So let's go through the same exercise, send the Dodge, and we get 63% for Warrigal, a dingo. So, and our husky is there in second position. So go ahead and play around with those models. They are super fun. And the last that I wanted to show you is a clip model that's been contributed to by OpenAI, also in this 4.6 release of Transformers. And with Clip, you have access to a multimodal experience, meaning that you can feed it text and it will return images for you that correspond to the task that you fed the model. It's not, we don't have a hosted inference widget for it yet, but you can download it using Transformers and set it up in your environment for demo. And if you want to, if you want me to demo that for you, let me know, and I'll look for a good demo. All right, so I have 10 minutes late for the 10 minutes left for the scheduled time. I've been talking for a long time. If you have any more questions, please go ahead and ask them now. And other than that, you can reach me directly at jeff@hikingface.co after this talk. Sebastian, maybe you already talked about it. I'm sorry, John, a little late, but in speech-to-text models, does it cover diarization? So yes, we have multiple tasks for audio, not just speech recognition, but also audio segmentation, separation. So the short answer is yes, but is it part of the ASR pipeline? I do not think so. Let me go back to the polls. I promised I would go back to the polls at the end. So we still have a similar distribution of usage. So I see that a third of you use Hugging Face for experimentation, and a quarter of you day to day. So for those who are exploring the world of Hugging Face and starting to use it to build new use cases at their company, I invite you to check out our premium support service, the Expert Acceleration Program. That's the best way that we are able to directly help and contribute and add impact and value to our users by directly supporting them and guiding them through choosing the best models, how to fine-tune it, how to deploy it, how to approach a problem. So I'll put the URL in the chat. And then I see that 40% of you have never used it. So welcome, welcome. And depending on how you approach it, you can either start from the open source and pip install transformers and take it from there and check the documentation and how it can apply to your problems. Or you can go to hf.co and explore the models to see what would be most applicable to you. And then what you guys use Hugging Face mostly for. So the majority of you to research models. So I hope that these demos walking you through all the different ways through which you can find models and use them was useful. And then a quarter of you to train models. So if you're training models, I encourage you to check out AutoNLP. I put the URL in the chat earlier. And then if you use SageMaker or are looking for an environment to train models in a more efficient way, then you can reach out to me or look at the different resources that we have to guide you through how to use Hugging Face in SageMaker. We've built a great integration working directly with them. So you have, by using this solution, you have the confidence that you're using all latest and greatest, you have access to as many models as possible, and it's going to work natively with all the great features of SageMaker like parallelism and so on. And then for the 15% of you, for the 3 of you who use Hugging Face to deploy models, then I talked a lot about our Inference API, which is our hosted service where you can just send an HTTP request and get the output from any of the models that we host. But as I said, we are super excited to work directly with some partners on a new solution that is targeting not just a 10x speed up, but a 100x speed up, meaning a single-digit millisecond latency. And so if this is something that piques your interest, so shoot me an email at jeff@huggingface.co. All right. So thank you so much, everybody. I'll stay here for another 5 minutes in case there are late questions that come on. But other than that, thank you very much, and have a great rest of MLOps world. Thanks, Jerome. Yeah, the top 10, I saw a demo very recently. We also worked with the Gradio team recently, and so now with the latest update from the Gradio library, there's a tight Hugging Face integration, so it's super easy to create demo apps with this update. All right, thanks all. I'm gonna tune out. It was really great talking to you, and yeah, don't hesitate to reach out if you have any questions. Bye-bye.